Okay, so we're out here today having a chat about satellite motion, which is, as you guessed it, just another sort of circular motion. Do a little bit of tree trimming there. And so, in this sort of circular motion, what do you think provides the centripetal force? Gravity! Bingo! And so, the first thing we need to be aware of on this is that the centripetal force, because it's provided by gravity, is going to be directed towards the centre of mass of the object that the satellite is in orbit around. And so we know that our centripetal force is provided by our gravitational force, but we can't just use the old F equals mg because we're out in space. We're going to have to use the gmm over r squared, and it's now that it's really important. Satellite's little m, object that it's orbiting around, bigger mass, bigger m. Let's write down those equations. That's Newton's universal force of gravitation and the centripetal force. mv squared over r. Now we know that for stable orbit, for that satellite to stay at a constant radius of orbit, those two forces have to be equal. Gravity has to exactly provide the centripetal force. So what would happen if gravity was providing more force than was required for the centripetal force? What might that look like? Instead of circular motion, it's going to be spiraling inwards. And what about if gravity's providing too little force for the centripetal force that's required? What's going to happen then? It's the opposite sort of spiral. So this one here is where FC is smaller than FG, and this one here is where FG is smaller than the required FC. Let's pop those two equations then, following through the stable orbit idea. Let's pop those two equations equal to each other and see what happens. That's interesting, isn't it? Look at that. We've got a little m on both sides of that equation. And so what we learn from this is that the mass of the satellite is completely irrelevant determining our circular motion. Cancel it off. And we can now do a variety of different things from this starting point. We can do things like think about the circle that our satellite is moving in. We can work out the circumference of that circle because we know it's a circle, 2 pi r, and we can work out, using that, an equation for the speed of the satellite. Speed is distance over time. We're going to assume that friction is negligible when that satellite's in circular motion. And so we can write it out as 2 pi r over t, that capital T being the period of orbit. Let's see what happens if we try and plug that in over here for v squared and try and work out an equation for the period of orbit. How long does it take to go round? So that's one rearrangement that we could do, and it's interesting to note that the period of the orbit, the time it takes to go around, depends on the radius of orbit cubed. Now, these are concepts we're talking about here. There isn't any one thing you have to do with this maths, but there are a variety of things that you could do, different ways you could put the equations together, just dependent on what the situation is that you're trying to solve. Let's have a go at an example. Right, what I want you guys to do is have a shot, taking a few things that I know off the top of my head. Like, I know that I see a full moon about once every 28 days, and I know that the Earth's 5.98 times 10 to the 24 kilograms. I want to know how far it is from the surface of the Earth to the centre of the moon. How far away is that? Calculate now before I do it for you. Hopefully you ended up with something like that. The radius is equal to the cubed root of gmt squared over 4 pi squared. Not often we get to do a cubed root, is it? 28 days is no good. Let's convert that to seconds. Gosh, that was a bit tricky. I forgot to square the t for a while there. That really caught me out. But in the end, I think I got 389,600 kilometres as the distance from the centre of the Earth to the centre of the moon. But the question I asked you was, how far is it from the surface? Do you remember the radius of the Earth? 6,400 kilometres. So that's my final answer.